Welcome, seekers of knowledge, to the fascinating world of chemistry. Today, we delve into a topic that is as intriguing as it is fundamental. Colligative properties. What are colligative properties, you may ask? Well, these are properties of solutions that depend on the ratio of the number of solute particles to the number of solvent particles, not on the nature of the chemical species present. In simpler terms, they're properties that depend on how much stuff you dissolve in a liquid, but not what that stuff is. Now, on to the heart of the matter, the different types of colligative properties. There are four main types: vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Each of these types represents a different way in which the presence of a solute can affect the physical properties of a solution. First up, vapor pressure lowering. This is the phenomenon where the vapor pressure of a solution is less than the vapor pressure of the pure solvent. Why does it happen? Because solute particles at the surface of the solution take up space that solvent particles would otherwise occupy, reducing the number of solvent particles that can escape into the vapor phase. Next, we have boiling point elevation. This occurs because the addition of a non-volatile solute to a solvent increases the temperature at which the solvent boils. The solute particles disrupt the equilibrium between the liquid and gas phases, requiring more energy or a higher temperature to boil the solvent. The third type, freezing point depression, is the opposite of boiling point elevation. Here, the addition of a solute to a solvent lowers the temperature at which the solvent freezes. Again, this happens because solute particles disrupt the equilibrium, this time between the liquid and solid phases, requiring less energy or a lower temperature to freeze the solvent. Lastly, osmotic pressure is the pressure required to prevent osmosis, the movement of solvent particles from an area of lower solute concentration to an area of higher solute concentration. This pressure arises because the presence of solute particles reduces the chemical potential of the solvent, driving the movement of solvent particles. Now let's summarize the key points about colligative properties. They are properties of solutions that depend on the ratio of solute to solvent particles, not the type of particles present. The four main types are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Each of these types represents a different way in which the presence of a solute can alter the physical properties of a solution. Lastly, a nod to Raoult's law, an equation that beautifully encapsulates the concept of vapor pressure lowering. It states that the vapor pressure of a solution is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. This law provides a mathematical framework for understanding how solute particles can affect the vapor pressure of a solution. And there we have it, a brief journey into the world of colligative properties. Remember, the beauty of chemistry lies in its intricate details and the ways in which seemingly simple concepts can have profound implications. So, keep questioning, keep exploring, and keep learning. Until next time, farewell.